series and parallel circuits. So if you consider series circuit, it's nothing but a closed path in which the current flows into only one path. So there will be only one closed path will be there, where the same current will be flowing throughout the circuit. And if you consider with the parallel circuit, there will be a different closed paths will be there, so that the current will be divided into two or more paths depending on how many circuits are there. So in parallel circuits, the voltages will be same and the current will be different, as there are different loops are there or different branches. But in consider with the series circuit, there will be a single loop, so current will be same, but depending on the how many resistors are present or the equipments are present in the circuit, the voltage will be different. So you can observe here, it's a single path is there, so the same current will be flowing throughout the circuit. But if you consider for the parallel circuit, this is a one circuit will be there, so this will be on different current and this will be on different current, so two loops are there, so two different current will be flowing in the circuit, but they are connected in parallel, the voltage drops remains same. Then how to identify? So this is one more example for your series circuit. Here you can observe the same current is flowing through both the lamps here. So then how to identify whether the resistors are connected in series or parallel? So to check the series circuit, there is two conditions we need to follow. The first thing is, if you consider two resistors, let us consider this one as R1 and this is R2. So usually all the resistors will have two terminals. So in that, if you want for the series connection, one terminal of both the resistors must be common. So you can see here, one terminals of both the resistors must be common. That is the first condition. And the second condition is that from this particular common point where both the resistors are connected, from that there should not be any other connection. So it has satisfied two conditions. One is one end of both the resistors must be common, and the second one is from the common point we don't have any other connection. Then these two resistors are said to be in series. So now for this example, R1 and R2 are connected in series. Now let us take one more example. This is R1, R2, R3, and this is R4. Now you can observe here, between R1 and R2, one terminal is common, and from the common point we don't have any other connection. So R1 and R2 are said to be in series. Again, if you consider R2 and R3, again one terminal is common, but from that common point we have R4 connected. So it is not satisfying with the second condition, so we cannot consider R2 and R3 are in series. So in this second example, only R1 and R2 will be in series. That is the condition we should consider. And now if you consider for the parallel circuit, so there is only one condition to be followed. Example, if this is the R1 and this is the R2, so both the resistors will have two terminals, both the terminals must be common. So if you consider two resistor or three resistors, example, we consider the three resistor, so usually that resistors will have two terminals, all the terminals should be common. If that is the case, the resistance are said to be in parallel. There is the only one condition we should follow, that is both the terminals of the resistors must be common, then they are said to be in parallel. So let us consider a simple example so that we can discuss with respect to the problem. So let us consider two ammeters. So let us consider two ammeters which are connected in series. So let ammeter be A and ammeter be B. Now we have two ammeters and the current flowing through the ammeter will be 20 amps. So both are connected in series. The first ammeter voltage drop will be 0.2 volt and the second ammeter voltage drop will be 0.3 volt. So now we need to identify if the ammeters are connected in parallel, how this 20 amp current will be distributed among the ammeter 1 and the ammeter 2. That is what we need to find. So that is the first condition they are given, both are connected in series, they are given the voltage drop and the current flowing through the circuit. They are asked us to calculate how the current will be distributed when 20 amps current source same itself is given, but when they both are connected in parallel. So if you want to find out the current flowing through the circuit, first we need to find what is the resistance present in this circuit. So in the second circuit we don't know the current, we don't know the resistance, so we cannot calculate. So that's why they are given the first condition. So in the first condition they are given the current, it's a series connection, so that the current flowing through both ammeter A and ammeter B will be same, and the different voltage drop they are given for ammeter A and ammeter B. Using this we can calculate the resistance. From Ohm's law we know that V is equal to IR. So you drop across ammeter A is given by I into resistance in ammeter A. So your RA is given by VA by I. So in this VA they are given is 0.2 and I is 20. So therefore we are going to get RA value as 0.01 ohms. Similarly, the drop across ammeter B is given by I into RB. So RB will be equal to VB by I. So here VB is 0.3, I is 20. So the resistance we are going to get will be 0.015 ohms. So that is what the resistance we are going to obtain here. Now we got the resistance across the ammeter A and resistance across the ammeter B. Now we can go with the second condition. So now for the parallel condition now. So the current flowing is 20 amps. This is ammeter A what they are given, and this is the ammeter B connected in parallel now. So for the ammeter A we have calculated the resistance value as 0.01 ohms, and for the second one we have calculated the resistance value as 0.015 ohms. So now we should identify what is the current flowing through ammeter A and what is the current flowing through the ammeter B. So now by using the current division rule, so if you want to find the current flowing through the ammeter A, so the current division rule says that if you want to find the current across any resistor, it is given by the total current into the opposite resistance divided by the sum of the resistances. So here if you want to find the current flowing through IA, the total current, that is I, into the opposite resistor, that is the resistance across the ammeter B, divided by sum of the resistor, that is resistance across ammeter A and B. Here the total current they are given is 20. Resistance across ammeter B will be 0.015 divided by sum of the resistance 0.01 plus 0.015. So if we simplify that, we are going to get the value of the current flowing through ammeter A, which will be around 12 amps. So then they have asked us to calculate the current flowing through ammeter B. So from KCL we can consider here, this is a node. If you consider the entering current will be 20 amps, that will be I, total current. The leaving currents will be IA and IB. So we can write from KCL, I will be equal to IA plus IB. So therefore IB will be equal to I minus IA, which will be equal to 20 minus 12. So we are going to get the answer as 8 amps. So the current flowing through the ammeter A will be 12 amps and the current flowing through the ammeter B will be 8 amps. So this is how we can solve the current flowing through both the ammeters. Now let us consider one more example. So let us consider a circuit with two resistors in series parallel along with a series circuit. To that one voltage source will be given. So the voltage value they are given is 200 volts. The parallel resistance they are given will be 20 ohms and the 40 ohms, which is in series with the 10 ohms. So we need to find the current flowing through all the resistors. So we need to find the current flowing through all the resistors. So if you want to find the current flowing through all the resistors first here, we should find out the R equivalent value here, so that we can calculate the total current using your Ohm's law. So if you want to find out the total resistance here, the 20 ohm is connected in parallel with the 40 ohm, then both are in series with the 10 ohm resistor. So, it is 20 into 40 divided by 20 plus 40. So, I am going to as 13.33 ohms plus 10 ohms which is in series. So, the total equivalent resistance we are going to get will be 23.33 ohms. Now, using Ohm's law, V is equal to IR. So, we can calculate I value which will be equal to V by R, which is 200 divided by 23.33. So, if you solve this, you are going to get the total current which will be 8.57 amps. So, now using this, you can calculate the current flowing through each resistor. So, example here, now we got the total current, that is the same current will be flowing across a 10 ohm resistor. So, the current flowing through 10 ohm resistor will be 8.57 amps. And next we need to find out current flowing through 20 ohm resistor and the 40 ohm resistor. So, now we can use the current division rule again. If you want to find the current flowing through a 20 ohm resistor, which is given by the total current we got is 8.57 into the opposite resistor which is connected in parallel with 20 ohm, that is 40 divided by sum of parallel resistor 20 plus 40. So, if you simplify this, we are going to get the answer as 5.71 amps. So, then the current flowing through 40 ohm easily we can calculate, that is the total current minus the current flowing through the 20 ohm resistor, which will be 8.57 minus 5.71 amps. So, if you use this, we are going to get the total current flowing through the 40 ohm, that is 2.86 amps. This is how we can calculate the current flowing through individual resistors.